Hi, my name is Mohammed Mudassir Yamin. I'm currently working as a research fellow at NTNU. Last night when I arrived here at Bucharest, I used my debit card to get some cash, draw some cash from the ATM. So the transaction was blocked for obvious reasons. So I will talk about like ATM security and the problems which we face, like in special in the future, like in Android-based ATM security. Uh, so these are like my qualification. Like I'm following certs. I'm also like have some 50 plus security research acknowledgements, and like I'm also like an Interpol innovation medalist, and I'm working like a system security group of at NTNU. So we make systems and break systems at the same time for like secure by design principles to develop some secure by design principles. So uh, yes. Yes. So my talk, I will first share like the introduction of the problem, that what problem we face in like ATM security. Then I will share the background of the problem and the problem itself. Then I will share the impact of that problem. That what the impact of this problem is related to Android ATM machine. Then I will share its solution and the future, like what do we have and what where we can go with that. So the introduction is like this, like Android like 5.0 Lollipop introduces like two new ways to configure Android devices for a single purpose. One is like app pinning and like one is like for lock task mode. In app pinning, Android home button and Android back button is available in an app, and app is pinned on the front of the screen. So it can be used for a single purpose only. And for lock task mode, like Android home button and back button is hidden, and it is like they have Android have a, like device policy control, so it can be only used for one purpose only. So this enable like Android to be used for like digital signage, uh, ticketing systems, and point of sales. So these are like single purpose uh, use cases for Android. And so in the background, like like support for Windows XP like ended at like April 8, 2014, and at that time 95% of the ATMs were running on Windows XP. So the whole industries were forced to move to Android. So at that time, like the largest ATM manufacturer in the world, NCR, like proposed this idea: why can't we use Android as an OS of the ATM? So they gave the following points, like Android is like is a like a free operating system. It reduced like the cost of like the whole ATM like to 27 to 40%, and there is no threat for traditional malwares in the Android ATM systems. And like they replace like ATM owners like replace their ATMs like with 3 to 4 years. So most probably the next ATM which you will use is most probably running an Android. So they argue that what could possibly go wrong by using Android in that scheme, in that ATM. The problem is that ANR is like when a UI thread of an Android app is like blocked for too long, so it's called like an application not responding. But you will be all too familiar with that. The best applications of like the Android, like Google Chrome, even Google Chrome has like the ANR events. So if the app is like in the foreground, the system displays a dialog box to the user, like then that dialog gives the user like the opportunity to force quit the app. This situation in ATM occur like in ATM, like they have like some input interface like the keystrokes and some other interfaces where you can give an input. Like if you give like a lot of keystrokes to the ATM machine, then most of the cases some error like this appears on the ATM machine. So if the user select close the application, then the whole kiosk break and the user will have access to the whole operating system of the Android. This is practically done by us in our system security group. So when we go back to our application and open it, we can see its impact. So the impact is that it gives you like full Android OS access of the ATM, and you can like upload like malwares on that ATM, like traditional malwares, and you can monitor the traffic of the ATM, and like you can also steal the source code of the whole APK that is running on that ATM. These are some examples. We got one ATM as a prototype for testing. So when we tested it, we were able to replicate that condition. We reached like the Android OS which is running on it, and then we managed to, it is connected to a bank network, so we managed to like make an internet connection from that ATM machine. After that internet connection, we just use like some traditional techniques to install some SSH over it. Like we first root that ATM machine, then install some SSH, and then like from the logs we were able to like retrieve multiple transaction details, which can be seen here as well. Mhm. We also like monitored its traffic by like installing our own, making it a proxy through normal bulk proxies to capture live transactions happening from the ATM machine. And we also like steal the keys and other code from the stuff. We retrieved the APK from the ATM machine, and like mostly we reverse engineer the whole APK for our own functionality. So doing things ethically, after we identified the problem, we also proposed the solution for those problems. So we proposed our own strategy for ANR event handling, because like Google provided strategy doesn't work. Seriously, they don't work because they told us like to increase the memory of the ATM and do most of the work not in the main thread, like in the sub threads. So, but we tried to implement those techniques, but we weren't able to achieve those results as scheduled by Google. And we also suggested some anti-malware, some SSL pinning with API call encryption, and some source code obfuscation. So we will discuss them one by one. So in the ANR event handling, we created our own model. It was published like in a IEEE. So we basically suggested like in a case of an ANR event, you basically have to like first restart the whole ATM to secure it, because there is no other option, viable option we could identify. We also limit like the card swipes and like the inputs from the keystrokes that are available in the ATM to reduce the input size and reduce the memory consumption of the ATM. Then we suggested to include anti-malware solutions. There are multiple anti-malware solutions available. So we suggest like to use like one of the best. Trend Micro is the best. So we suggested to like use one of the best malware in the ATM to just avoid some malware and stuff like that. For SSL pinning, we also force like the ATM to like use a specific CA certificate authority for like HTTPS communication, and we also like implemented like the API calls encryption with S, like to provide an additional layer of security. It is not like a permanent solution, but this is the only solution we have. So for source code obfuscation, we implemented like source code obfuscation, like in the prototype, like we obfuscated the code of the whole APK, so it is not readable and like reverse engineerable. So we can suggest like to use tools like ProGuard and DuxGuard for like the source code obfuscation. Now, in the future, there is always light in the end of the tunnel. So these are like some statistics from single European payment area. It is like the research is done by European Secure Transaction Association. So you can see like the ATM related transaction frauds are reducing with respect to time only in Europe. Like they are currently like at 5%, like compared to rest of the frauds. These are some other statistics from that. They're like at the lowest point in like the history in Europe at that time. But in the rest of the world, like the ATM related frauds are like increasing. This is why, because in Europe, like we have some secure transaction solution implemented, like smart cards and stuff like that. But in the rest of the world, like in US, like the smart chip technology isn't implemented yet, so that's why we have those transaction related idea problems. So this is my whole presentation. Thank you. Any questions? Any questions?
Okay, Mohammed, thank you so much. That was quick. So, no questions around? Nobody wants a free hat or a t-shirt, a cool one? So it was a cool presentation, isn't it? Okay. So I have a question for you, Muhammad, in that case. So what were the challenges? So we'll need an extra mic. So Mihai, can you help us with the extra mic? Or, yeah, thank you. So what was the most challenging thing you encountered during the research?
Identifying the problem is like the most challenging thing, because when we are presented that ATM machine, we don't know what to do with it. So we tried everything, that we tried to like brute force, we try to open its back, like they have some screws, because in an ATM scenario you have physical access of it, like in a normal scenario. So, and thief can do whatever he want if he can break like the back of it. In the back, they have some USB ports as well, but we discredited those scenarios, like because they told us, like the ATM vendor, like NCR told us, like they are going to secure it anyway. So then we focused on like the interface on the network. They like use SSH2 for the communication of the ATM. We even exploited that, but they said like it's a prototype, so for a prototype they only allowed SSH, but for normal case they will not allow like some SSH connections. But then we focused on like the keypad and stuff like that for inputs, and make like a large amount of input. Then when we realized like the ATM performance is degrading with respect to inputs, then we realized that it will probably cause a crash. So then it caused a crash, and we achieved these results.
Okay, that was cool. Thank you so much. So, yeah, we have a question.
How have you managed to trigger the error application not responding?
Yes, I was telling you, like we inserted like a lot of, we like pressed those keystrokes like maybe like 1,000 times before that error happened. We continuously swiped the card in the ATM machine, and continue to press like the button, because whenever you swipe the card in the ATM machine, it reads the card information. But we were just swiping it not for like legitimate purpose, for illegitimate purpose. And we are continuously pressing the keys, and there was one special key in that prototype, is like the cancel key. A cancel key like normally do like clear the input, but we are pressing the inputs and continue pressing that button as well. So that crash caused the crash.
Interesting, thank you.
I'm sorry, I think I didn't get that part right. Is it ATMs were using Windows and they switched to Android?
Yes, yes. As I told you in my presentation, like in 2014, like Windows XP is retired, so they have no option to switch to, like they have only option to switch to Windows 7, but they decided to like go for Android, because Android is free and they can customize it whatever they want, however they want.
Thank you.
Thank you so much, Muhammad. So, yeah, we have another one. Okay, so we need a mic. We need 3 mics in a room.
Hey, so what does the actual additional layer of encryption protect against? So you said your mitigation was adding AES encryption on top of what was already present.
When like HTTPS is implemented, like you can bypass the HTTPS transport layer security by installing your own certificate on the Android machine. Like it is a very common trick used in burp. So you just force the application to use your certificate for TLS SSL encryption. So you can see the HTTPS traffic in clear text. So what we suggested is that you use like SSL pinning, like force the application to use a specific certificate, and also encrypt the HTTP calls with the additional S, like the API call. So if the attacker was able to bypass the SSL pinning, he will have like not clear text, but like a ciphertext to deal with. But in case, because in Android, like you have to store like the S keys on the device as well, so it is also prone to like, reverse engineer other attacks. But we are also implementing like source code obfuscation that avoid this problem, hopefully, because people are able to bypass this vulnerability as well.
Thank you very much.
No problem. No one?
Okay then. Any other one? We have one, Mihai. We have that nice lady there.
Yes. No, it's okay. It's okay.
What mitigation solutions are there already on the market? And what does your solution bring in addition to those existing ones?
Yes. Actually, in the market, like what Google suggests is like they suggest like to follow secure coding practices, like in the application development that is being deployed on the Android. But we analyzed multiple Google applications themselves. Like in Google Chrome, they also have like those ANR events, and we realized that it is like insecure by design. The Android OS is like insecure by design, so we have to do some other. We have to find some other ways. So we only suggested like in the case of like an ANR, we only find like one probable solution is like to force restart the application to like clear the RAM of it, because we try like to implement like a garbage collector, stuff like that in the Android, but we failed with that. So this is the like a new solution for that problem, because it will avoid like the Android OS access, which led to like the whole Android system compromise, the whole ATM system compromise. But it will just restrict the user for like 1 minute or less than 1 minute for the usage of the ATM device. And related to like market, that thing is like quite new, so there are very little solutions available for that. Like there are some IBM's like mobile device management capabilities, so you can integrate that with their ATM machines to get like some SIEM, to integrate with your SIEMs and get a lot of logs and information and stuff like that.
Thank you.
Okay. Any other?
Are there any standards or any guidelines you have to follow in this industry? Because this is
Yes.
a critical infrastructure, and
Yes.
any attack can cause a lot of
Yes.
problems.
There is like payment card industry, digital security standards. You have to follow those standards for anything related to like ATMs and payment cards.
Okay, thank you.
Okay.
Hi. You mentioned about source code obfuscations
Yes.
As a measure to protect an ATM. Is this measure safe enough? I experienced with some obfuscators, and actually they are not so good. What is your opinion about that?
It's like only a layer of security in the whole scheme of things, because it's like an onion approach. You create a layer and another layer, another layer. So it is like one of the layers. So before like source code obfuscation, we have like the force application restart and like malwares, anti-malwares, and the source code obfuscation is implemented in the case only when the APK is the APK of the ATM application, like the bank application, is get in the hands of like the hacker. So for getting that in hand, you have to compromise the ATM machine. So that's why we like introduced a multi-layer security. So in the worst case, he can get the thing but it is obfuscated, so he can probably use some statistical analysis techniques to, because like I think like from ATH Judic they implemented like a statistical analysis approach, like from Stack Overflow they analyze like thousands of Android applications and like obfuscated Android application and unobfuscated Android application, and like created a statistical analysis approach to deobfuscate the whole thing. So it is possible to deobfuscate it, but it's just a layer of security.
Thank you.
Hi. About the NRRs, so you told us that it's, you get the too long not responding thing when you click most of the buttons, right? So can't you just have something that counts and mitigates that? Because it's probably not very smart to have the opportunity to click how much as you can, so you can just restart the application, not the whole ATM.
If when you try to restart the whole application, so the kiosk mode is like crashed. So we thought about it, but
It's not possible.
not possible.
It's not
at
possible,
The,
okay.
at that in that
So
prototype.
the NRRs, they're coming like from the Android API, so...
It is coming from Android OS.
Okay, from the Android
Yes,
OS,
yes.
so isn't it some way to bypass it, like something, I don't know, on low level, I mean?
Low level, I think like it's like the basic functionality of the Android, so
Okay,
you have
yeah.
to change like the whole OS. For,
Yeah, it's because
yes.
of the application
Yes,
life cycle
yes,
and so on. Yeah,
yes.
I know what you mean. Okay,
Yes.
thank you.
No problem.
That's